problem 4, and it's a related rates question, and it's a shared problem for both the AB and BC 2019 FRQs. And on that note, I forgot to say that problem 3 is also shared. I titled it as if it's only a BC, but clearly you can use it for the AB also. It's the same question. Okay, cool. All right, now I've summarized this question here, and yeah, so part A is what is dV/dt at h equals 4. Okay, so we know that the volume of a cylinder is this here, right? And so right away, because the radius, which is 1 since the diameter is 2, does not change. The radius doesn't change. So I can replace this r here with 1, and so reduce the volume equation to pi times h. But let's have fun. Let's not do that. And so now we're going to do implicit differentiation with respect to t. And so we have a product here. Yeah, and the product is between pi r squared and h. So we see that dV/dt is going to equal, it's going to be 2 pi r and then dr/dt times h, right, like that, and then plus pi r squared times dh/dt. The derivative of h is just 1, and then dh/dt. And so we need to figure out dV/dt at h equals 4. So that's this here, and that's this here, right? Okay, now, as I said, the radius doesn't change, and therefore dr/dt, the rate of change of radius, is 0, because it doesn't change. But if this is 0, this whole thing is in a product, so this whole thing is 0. Yeah? Okay, cool. So we see that dV/dt at h equals 4 is simply equal to, and we know that the radius is 1 at all times, so pi times 1 squared is pi, and then dh/dt we're given, it's right there, so that's negative 1 over 10 times root h, and h is 4 here, so that's root 4, which is 2. And so if we simplify this, we get negative pi over 5, and then it's going to be feet cubed per second. And it's feet cubed per second because here, even though r is 1, it's measured in feet and we've squared it. And then dh/dt is in feet per second. So we have feet squared times feet, so that's feet cubed per second. Yeah? Okay, cool. All right, so that's it for A, and let's move on to B. I'm better off doing this, I swear. Okay. So what does B say? B says, right here, is dh/dt increasing or decreasing when h is equal to 3? Well, to figure out if dh/dt is increasing or decreasing, we need to look at its derivative. So we need ddt of dh/dt. And so that is d squared h dt squared at h equals 3. So at h equals 3. Now, since we have dh/dt is equal to negative 1 over 10 times root h, which is h to the 1/2, we see that if we take the derivative of dh/dt, we get the second derivative. That is going to be, what is that going to be? It's going to be negative 1 over negative, that negative, and then 1/2, right? The power rule. So that's going to be 1 over 10 times 1/2. So that's, what is that? 1 over 20, right? Okay, and then h to the negative 1/2 power, right? But then dh/dt times dh/dt. Okay, now h to the negative 1/2 power is like root h in the bottom, right? So I'll just write that, root h, right here. Yeah, okay. And we need to look at this when t is equal to 3. So when t is equal to 3, we get negative 1 over 20 times root 3. And then dh/dt when t is equal to 3 is going to be, right, this part is dh/dt at t equals 3, rather at h equals 3, my bad guys. So at h equals 3 is going to be what? Well, it's going to be negative 1 over 10 times root 3. Now, look at what happens. We can cancel this, right? And so we have negative 1 over 20 times negative 1 over 10. That's positive 1 over 200, and this is greater than 0. So as this is greater than 0, the rate of change of dH dt is greater than 0 at h equals 3, we conclude that it is increasing. Yeah? Okay, cool. That's that for B. And then on to C. C is a very basic separable equation question, right? So we're given the initial condition that h of 0 is equal to 5, and we have to find h of t. Okay, so since we know that dH dt is equal to negative 1 over 10 times root h, if we separate the variables, we get dH over root h is equal to negative 1 over 10 times dt, and then integral, and so this here is h to the negative 1/2, right? It's h to the negative 1/2 dh, right? And so that's going to be h to the positive 1/2 divided by 1/2, so I could just throw a 2 right there, and that's 2 root h, right? So, and h is a function of time, so we have 2 root h of t. We want to be very clear, and then plus a constant. Let's call this first constant c1, and then on the right hand side we have negative 1 over 10 times t, and then plus a constant 2. Now we can combine constant 1 and constant 2 to just one constant, and let's call it c, so plus c. Yeah? Okay, cool. So ultimately what we're after is solving for h of t and determining c based on the initial condition. Now, we could first figure out what h of t is by itself and then use the initial condition, or we can do it here because we've already done the integration part. So I'll do it here. So we get 2 root h of 0 is equal to negative 1 over 10. T is equal to 0, right? That's what that means. So 0 plus c. So h of 0 we're told is 5. So 2 root 5 is equal to c, because this here is 0. So we see that 2 root 5 is c, meaning instead of c here, I could put 2 root 5. And let me actually scoot everything closer. So equals negative 1 over 10 times t, and then plus 2 root 5 now. Right? Okay, so we want to solve for h of t completely, and I'll divide by 2, so that amounts to changing this 10 to a 20 and getting rid of that. And finally, I'll square both sides, which means I do this, and I do that, and we are done. Yeah? Cool. All right. I hope you enjoyed this. Keep watching. Take care.